Hello students. In this little video we're going to work through one of the homework problems. That way you have a little bit better example, hopefully, of how to do some of these. So this problem is number 25 at the end of the chapter. So if we look at the circuit here, we have a current source, we have a resistor, and we have a capacitor. Before we can start analyzing this, the first thing we need to do is pay attention to the values. So we see that the current source is listed as 10 cosine 3t plus 45 amps. Then the resistor is 4 ohms, and the capacitor is listed as 1/6 farad. We also see that we need to find the current through the 4 ohm resistor, and we also need to find the voltage across the capacitor. These are the two outcomes. If you remember anything from the chapter, you'll know the reactance is what we need to know most. And reactance is a form of resistance. So our resistor, we know its resistance value, 4 ohms. But the capacitor, we don't know its resistive value. We have to calculate that. So that's going to be our first step. So we do that with the equation 1 over j omega c, or 1 over imaginary times the frequency domain times the capacitance. So if you remember, j is our imaginary. We use the lowercase script j as opposed to the I that most mathematicians use. Omega is the first part of the source value in parentheses. So if we go back to our source, we got that 10 cosine, open parentheses. The first part in that, the 3t, t indicates the time point in the sinusoidal wave, and 3 is the frequency portion of it. So the 3 is going to come over and be a part of it, and then the capacitance is the 1/6 farad. So we can fill that in to where our equation is now 1 over j times 3 times 1/6. We can solve that out to 1 over j2. Now 1 over j is the same thing as negative j. It's inverse. So we can solve that out as negative j2. It's a little bit easier to write than the 1 over j2. Now we can turn our attention to the source. It has that long explanation of it, 10 cosine 3t plus 45 degrees. Now that 3t portion is our frequency aspect and the time domain. For this point of the analysis, we don't really need to know that. It's not going to factor into how we solve these equations because we're not trying to find an instantaneous value. So we can disregard the 3t for this portion, and we can rewrite this in a polar fashion as 10 at an angle of 45. So now with these two new values, I'm going to redraw the circuit using these values in place because it's going to look a little less confusing. So here we have the source of 10 at an angle of 45 degrees, 4 ohm resistance, and negative j2 capacitance. Now we can focus on what it is we need to find. And I'm going to start with current. So we need to find the current through that 4 ohm resistor. But to know this current, we have to know all the currents. So here I've gone and labeled the other currents in this circuit. We have IT, which is the current coming from the source, and then we have IC, which is the current through the capacitor. And that's all 3 branches in this circuit. To solve this, I'm going to have to use Kirchhoff's current law. It states that all the currents at a node must equal 0, or all the currents entering a node must equal the currents leaving a node. So I can use the current divider to find I. And if you remember correctly, the current divider rule that we learned back when we were doing DC was the total current times the resistance of the opposing branch divided by the resistance of the branch we want to find plus the resistance of the opposing branch. That's the total current multiplied by the resistance of the opposing branch divided by the total resistance in the circuit. In this case, we're having to deal with reactance. So it's going to be the total current times the reactance of the opposing branch divided by the total reactance. Now one note, if you remember when using the current divider, we can only use it on 2 branches. If we have more than 2 branches, it won't work But in this case, we have the perfect number of branches. We have 1 input, 2 outputs. So that's not going to be an issue. The values we'll use on that are 4 ohms for the branch that we're trying to find, and then negative J2 for the opposing branch. The input current is the 10 at 45 degrees. So our equation is going to be 10 at an angle of 45 times negative J2 over negative J2 plus 4. That's the opposing branch over the opposing branch plus the branch we want to find. And you can see it here on my calculator how I'll put that in. If you need a little bit further help with how to input this into the TI Inspire, just send me an email and I can explain that to you a little bit better. You can see here that my calculator, because of the settings that I had it on, it spit it out in rectangular form. We started in polar, but it spits it out in rectangular form. I'm going to end up converting this back to polar because it's a little bit easier to read, and that's also the way the book has it, so you can verify your answer. In this case, the book is actually correct. So you can see that it gives me 4.47 at negative 18.43 degrees as an answer. And that is the current flowing through the 4 ohm resistor. Now I'm going to express this in the domain of the source, so I'm just going to rewrite it as how the current source value was originally written. So here I have 4.47 times the cosine, parentheses, 3t minus 18.43 degrees amps. And that's the current flowing through the resistor. Now we can focus on that voltage that is across the capacitor. That's the other thing that it asked us to find. Now I want you to take a sec and think, how can we find that voltage? You may think that, all right, now let's find the current flowing through that capacitor, and then we'll just do Ohm's law, current times reactance. Well, there's actually an easier way. Because if you paid attention, you know that this is just a simple parallel configuration. The source is in parallel with the 4 ohm, which is in parallel with the capacitor. So, the voltage across the capacitor is going to be the same as the voltage across the resistor. We already know the current flowing through that resistor. So now we can multiply resistance times current and we'll get our voltage. So, we're going to do 4.47 at negative 18.43 degrees times 4. Now, I just used the retained values in my calculator, and so you can see it's worked out to many more decimal points than if I just did it, so I'm going to have a more exact answer here. Now, you can use the rounded numbers that you had written down on your paper. Your number is going to be slightly different than what I have. Don't know how far off, it all depends on your calculator. But when I do this math, I get 17.88, or let's round up 17.89 at an angle of negative 18.43 degrees. You can see the angle didn't change here. That's the key thing because the resistor doesn't affect the angle at all. The source and the capacitor affect the angle. And since we've already calculated the angle based on the capacitor, it's not going to change across either of these. So, the voltage across the capacitor is 17.89 cosine 3t minus 18.43 degrees volts. And that is this equation broken down into its simplest components. You should be able to take this process and apply it to any of the other circuits. Some of them may be a little bit harder, some of them may be a little bit easier. The one thing you have to watch out for is sometimes it'll give you values in sine and one value in cosine. You have to convert one to the other before you can do the math. So if your source is listed in cosine, but then you have a capacitor and it gives you the value as a sine, you have to convert that sine to cosine. That way you can do the math correctly. If you have any other questions on this topic, please feel free to shoot me an email at any time and I'll do my best to explain it. Thank you and have a good day.